Hello everyone. I am Om Prakash. I am going to teach you what is DFA. Let's see what is DFA. DFA refers to deterministic finite automata. Deterministic refers to the uniqueness of computation. The finite automata are called deterministic finite automata if the machine can read an input string one symbol at a time. In DFA, there is only one path for specific input from current state to the next state. In a DFA, if you see from one state to the other state, there can be only one path and there cannot be multiple paths. DFA does not accept to the null move, that is, the DFA cannot change state without any input character. The DFA can go to one state to the other state only if it acquires an character. Without acquiring any character, it can't go from one state to the other state. DFA can contain multiple states. It is used in lexical analysis in compiler. First, see how a DFA looks. A DFA can be represented by diagrams called state diagram, in which the state is represented by vertices. Here you see A and B. The A and B are vertices. The arc labeled with an input character shows the transitions. Above A, you can see there is one arc, which represents the one above it. This is a transition. And above B, there you can see an arc, and from B to A, there is an arc. These are called transitions. The initial state is marked with an arrow. In A, it is an initial state. That's the beginning. So it should be represented with an arrow, and above that it should be named with start. The final state is denoted by a double circle. Here the final state is B. It should be denoted by a double circle. Tuples of DFA. A DFA usually has 5 tuples: Q, sigma, Q naught, F, and delta. Q is nothing but the finite set of states. The states are the number of states which we are using to represent the DFA. And sigma is nothing but the input symbols which we give inside the DFA. Q naught is initial state, F is final state, and delta is the transition function. Let's understand it completely by solving the problems. Before solving the problems, let's see what are the important notations that we should know. Clean closure and positive closure. Clean closure is nothing but A power star, and positive closure is represented by A power plus. A power star equal to, it contains epsilon, which is nothing but the empty set or null string, you can say it as, which is nothing but A power 0. So A power 0 is nothing but an empty, so it is represented by epsilon comma A. Then A is nothing but A power 1, it is A power 2, A power 3, A power 4. That is, A power star can contain values of A power 0, A power 1, A power 2, A power 3, and it goes on like that. But in a positive closure, it doesn't contain A power 0, that is, it lacks the epsilon. So here it just contains from A, that is A power 1, that it begins from A power 1 and it goes up to n time. So the main difference between these both is it can have null thing, that is the epsilon, but it doesn't have the null value. It begins from A power 1 only. Okay, let's go to the solved examples. Before going to the solved examples, we need to know 4 steps to be followed while solving the problems. Step 1 is write 7 to 8 possible strings for the given language. The question will be given in the form of a language where we need to write 7 to 8 possible strings from the language. Then in step 2, draw the transition or state diagram for it. We are going to write the 7 to 8 possible strings. From the possible strings, we are going to draw the state diagram. From the state diagram, in step 3, we are going to derive the transition table. And in step 4, using the state diagram and state transition table which we drawn earlier, we are going to write the tuples from it. Okay. Here is the first question. L equal to omega, where omega belongs to A comma B. Omega is nothing but the symbol which is used to define the string. So L is equal to omega, where the string contains A comma B. That is, the string contains only the letters A and B. And here it's a clean closure operator. Clean closure operator is nothing but the A power star. A power star means it also has the epsilon value and it has A power 1, A power 2, and it goes on like that. And ends with B. They are given a condition that the string must end with B. Let's solve it step by step. And here's the step 1. Write 7 to 8 possible strings for the given language. First, for the language, B comes the first string. Let's see how that B came. They are given that ends with B, so every string which we derive should end with B compulsorily. We had already learned that in clean closure there will be a null string or null value in it. So as it contains a null value a comma b or star, so null value is none other than epsilon. When we combine epsilon with b, that is the null value with b, it comes b. So we write the first value as b. Next, after epsilon, there is a power 1, a power 2, and it goes on like that. Let's input this a or b one by one into it. Let we should remember that it should always end with b, and before that we will add strings like a. We can add n number of a's, and also we can add b. We can add n number of b's to it. It's not. We need to understand one thing here. It's nothing that we should add only a before it or only b before it. We can also add both before it. Like here, b a b a b b. We can add also both before it. As we had done with the step 1, let's go to step 2, where we need to draw the transition diagram from the L, which we from the set of 7 to 8 strings which we had done before. The main thing which we should remember is the minimum length string we need to write in the L while writing those 7 to 8 strings, because that helps in drawing the transition of the state diagram. Let's see here how it helps. Here the minimum length string is B. So we wrote here the B. So let's understand how it came. Here the minimum length string is B. Let's check how much characters it has. Only one. So only one means one. We need to add plus one to the number of letters in the minimum length string. Here it's one. So one plus one is two. So there will be two states in the whole DFA diagram. That's how this came. Let's name the states with whatever we want. Like let it be A, B. Okay. First B. First okay. Here it's nothing but when A gets B, it goes to B. That is, A is getting the B and it's going to the end state, which is nothing than B. Let's see how we can derive all these things into it. When it comes A, B, we can create a self loop in A so that A and it will go to the end state. So A and it's B. Let's see how A, B can come. See, in a self loop, when it comes to self loop, it can't go to any other states. It will be in the same state. When A gets an A, it will be in the same state A, and again when it gets an A, B is in the A, and when it gets to B, it goes to the end state. See, we need to construct a DFA in a manner such that when we get the B, it should go to B. That is the final end state. It should not be in A or some other states, because here B is the final state. So whenever we get the final letter or the final character in the string, it should be in the end state. Okay, now we are constructed of this. Let's see how B comes into it. When we get a B, we go to B. That is the end state. So again there we need a B. So what we can do is we can add a self loop to B. So now we see from A, when it gets the first character B, it goes to B. When it gets the second character B, it remains in the end state and it satisfies the conditions also. Let's see what happens when it comes to 3B. In first B it goes from A to B, then in second B it will be in B, and when it goes to third B it remains in the end state itself. Then when it comes to AB, it will be A and it will be B. When it comes to BAB, when it gets the first character B, we go to the end state. But we have still more states like A and B, still more characters A and B. So let's see how we can bring into it. Here you see, when it gets the second character A, it goes to the A, and finally when it gets the third character B, it goes to the end state. This is how we will draw the state diagram. With this state diagram, we are going to write the transition table. Let's see how we can write the transition table. Here it's delta, and here we write all the states we had used in the diagram. Here we use just two states A and B. So here it's A and B, and we had used Here we are going to write what are the symbols which we are used to declare the string. Here it's A and B. So let's see how these four values came. Delta, A and small a. That is nothing but in the state A, when it gets the small letter A, where it goes. It, it's a self loop, so it comes back to A itself. So that is what this A. This A represents the final state when this initial state acquires this character. Let's understand it with these three, A and this B. When the state A gets the character B, it goes to the end state B. That's why here B came. Similarly in B, when it gets the character A, it goes to A. So that's how here A came. And when it gets B, it's a self loop, so it remains in the B, so it's a B. This is how we will write the transition table from using the transition diagram. Let's write the tuples using. This is the final step while solving the problem. So let's see how we write those tuples. While writing the tuples, we already saw there were 5 tuples: Q, Q naught, F, sigma, and delta. Q is nothing but the number of states we had used. So here we use two states, A and B. Those two states we are going to write here. Q naught is the initial state, that is A. F equal to the final state, that is B. And sigma is equal to A and B. These A and B are the symbols which we used to derive the string. Then let's see how this delta came here. For this, we need to see the transition table. So delta of A comma A. The similar way how we wrote the table, we are going to write it here. A comma A, it comes A. So we are going to write A comma A equal to A. And similarly, A comma B equal to B. B comma A equal to A, and delta of B comma B equal to B. This is how we write the tuples. These are the 4 steps which we use to solve this problem, and these are the main steps. So we had completed solving the first problem. Let's go to the example 2 so that we can understand it much better. L is equal to omega, where the string contains symbols 0 and 1, and it's a clean closure, and 0, 0, 1 is a substring. Let's understand this question, what they have given. That is 0, comma 1. That is, the string should contain only two symbols, that is 0 and 1, and it's a clean closure. They had given that star over there. That means that it's a clean closure operator. That is, clean closure operator means it even has the null value inside it. That is the epsilon. And they had given a condition that 0, 0, 1 is a substring. Whatever may be the string we derive, it should compulsory contain 0, 0, 1 into it. So let's write 7 to 8 possible strings for the given language. So the first thing is similar to the before thing. The first thing will be the substring itself, because as it's a clean closure operator, in clean closure operator, the null value becomes the first thing, which is epsilon. So null along with 0, 0, 1 is nothing but the 0, 0, 1 itself. So L equal to 0, 0, 1 becomes the first possible string, and this is the minimum length string also. Next, we can add zeros or ones or both zeros and ones into the substring. Remember one thing, that we can add zeros or ones before the substring or after the substring, but we cannot add between this. If we add between this, it, for example, if we add 1 between this, it will come like 0, 1, 0, 1. Then 0, 0, 1 is a substring. 0, 0, 1 will not be there in that string. So it deviates from the condition. So we need to be careful with it, that make sure that 0 and 1 can be added either before it or after it. So in that manner, we have derived here 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 0. Similarly, we can create 7 to 8 possible strings from this. Okay, now with these possible strings, we can go to solve the next step. Here the next step is to draw the transition of the state diagram from the sample strings which we had derived. The first step is to take the minimum length string. Here the minimum length string is the 0, 0, 1. I had already told that the length of the minimum length string plus 1 gives the number of states we are going to use in the DFA. Here the length of the minimum length string is 3, 0, 0, 1. So 3 plus 1 is 4. So the total number of states we are going to use is 4. So let's mark it as A, B, C, D, and beginning is marked by a start and the end state is marked by double circles. Now let's see 0, 0, 1. You can derive 0, 0, 1 using this diagram. When it comes to 0, 0, 0, 1, see, with 0 it goes to B, and another 0 it goes to C. But there is another 0 here. Within that, before that another 0, what we need to do is we need to add a transition here. So now if you see 0, 0, and if it gets the third 0, it becomes a self loop here, and when it acquires the 1, it goes to the end state. Similarly, if you see 1, 0, 0, 1, in A we are getting a 1. That means in A if we get 0, we are going to B. That means if we get 1 means what we need to do is just do a self loop here. See, now it's 1, 0, 0, 1. Even now we can derive this string also using our transition table. Now let's see 1, 1, 0, 0, 1. That is, for first one it makes a self loop, second one it makes a self loop, and the remaining two zeros it goes to here, and the remaining one it goes to the end state. So even this works perfectly. Next is 0, 0, 1, 0. See here 0, 0, 1. Within one it had came to the end state, but we had another symbol 0 in it. So what to do is just add a self loop with it. So now if you see 0, 0, 1, 0, we can derive from this thing. Next is 0, 0, 1, 0, 0. If you see here 0, 0, 1, 0, we can again do the self loop to get the fifth 0 also. So even it works perfectly for this also. Next is 0, 0, 1, 1. If you see here 0, 0, then with getting 1 it goes to D, and they had finally given an 1. So what happens when it comes to the fourth one? When it comes to the fourth one, we are making it a self loop. Now if you see 0, 0, 1, 1, even this works fine. Even if you go to 0, 0, 1, 1, here you can see 0, 0, 1, and again you can do two self loops to derive this string also. When it comes to 0, 1, here you see when it comes to the first string 0, first character of the string 0, it came to B. Next the second character is 1. What happened? What we need to do is add this transition to A. Now if you see 0, when it gets for the first 0 it goes to B, and when it meets the first one it comes here, then the third character, then the fourth character, then the fifth character. Even this works perfectly for it. So this is how we will draw the transition diagram for this. Using this transition diagram, we are going to write the transition table, similarly what we have done before. Here we are going to write all those states, and we are going to write the input symbols which we had used to derive those strings. See, when in the state A, when it acquires the symbol 0, where it goes is it goes B. See here, when it gets the symbol 0, when A gets the symbol 0, it goes to B. So here it's B. When A gets 1, it's self loop, so it's 1. Similarly, we can write for all of this. Then using these both transition table and the transition diagram, we are going to write the tuples for it. So basically there are 5 tuples, similarly what we had learned earlier: Q, Q naught, F, sigma, and the delta. Q is nothing but all the states which we had used to draw this: A, B, C, and D. And here Q naught is nothing but A, that is the starting state. F is the final state, which is nothing but D, and sigma is 0, 1. Sigma is nothing but the alphabets or the characters or the symbols which we used to derive the string. Here we are used only 0 and 1. And this delta a comma 0, a comma 1 is similar to how we got the transition table. Just using this transition table, you can write from here delta a comma 0 will give you this B, that is equal to delta a comma 0 equal to B, delta b comma 0 equal to C. Yeah, from this we can use it. This is how we are going to solve those problems in DFA, and this is what DFA is. Thank you.